Assalamu alaikum dear students. Today we are going to discuss the sum of the n terms of some special series. We discussed the sum of the n terms of AP, we discussed sum of n terms of GP. Now we will discuss the sum of those sequences which are not either AP or in the form of GP. Now the first one is 1 plus 2 plus 3 up to n. It is arithmetic progression, and the sum of the first n terms, you know how to find sum of the first n terms of AP, and you proved it to be n into n plus 1 upon 2. Now we will find the sum of the first n squares, that is 1 square, 2 square up to n square. Let's assume that this Sn is 1 square plus a 2 square up to n square, and in summation we can write this as summation k runs from 1 to n k square. Now if we consider an identity k cube minus k minus 1 whole cube, now after simplifying this and using a minus b whole cube, we simply get this k cube minus k minus 1 whole cube is 3k square minus 3k plus k. Now put k equals to 1, we get 1 cube minus 0 cube equals to 3 into 1 square minus 3 into 1 plus 1. Name it equation first. If we put k equals to 2, it is 2 cube minus 1 cube, which is 3 into 2 square minus 3 into 2 plus 1. Name it second. K equals to 3, it is 3 cube minus 2 cube, it is of this form. Similarly, k equals to n is n cube minus n minus 1 cube equals to 3 into n square minus 3 into n plus 1. Name it equation n. Now adding these equations, when we add here, this 1 will cancel this with 1 cube minus 1 cube, 2 cube will cancel with this 2 cube, so on to n cube will cancel this 3 cube will cancel with here 3 cube, and this n minus 1 in last minus 1 equation will cancel with this n minus 1 cube. So from in LHS we simply get n cube minus 0 cube, that is simply n cube. Similarly here we have 3 1 square, 3 2 square, 3 3 square, 3 4 square up to 3n square, which is taking 3 common, we get 1 into 3 into 1 square 2 square plus so on to n square. Here we have minus 3 1, minus 3 2, minus 3 3, minus 3 n, which is minus 3 into 1 plus up to n. And in last we have 1 plus 1 plus 1 up to n times, that is 1 plus 1 plus 1 n times. Now here it is 3, 1 plus 2 square plus n square is actually Sn, that is summation k runs from 1 to n k square minus 3 into 1 to n is by first, it is n into n plus 1 by 2 plus n. So simplifying this, we simply get n cube plus 3 by 2 n square plus 1 by 2 n equals to 3 Sn. Now taking n cube and 1 by 2 common, so we simply get n by 2 equals to n by 2 into 2n square plus 3n plus 1 equals to 3 Sn. Again simplifying this quadratic equation, we get Sn equals to, at the end we get Sn equals to n into n plus 1, 2n plus 1 upon 6. So this means that the sum of the first n squares, or if we have a sequence whose terms are the natural squares, then the sum of the first n terms of that very sequence is n into n plus 1 into 2n plus 1 upon 2n plus 1 upon 6. So this is the sum of the series of this finite sequence. Similarly, if we are asked to find the sum of the first n cubes, then this first n cube sum is n into n plus 1 upon 2 whole cube, because this sequence, if we consider 1 square, 1 cube, 2 cube, 3 cube, this is neither AP nor GP. So this is simply a general sequence, and its sum is n into n plus 1 upon 2 ka whole square. Now if we consider an identity, like we consider in the first 1 square plus 2 square identity, here we will consider an identity k plus 1 raised to power 4 minus k square equals to, which is 4k cube plus 6k square plus 4k plus 1. Now putting k equals to 1, 2, we get n equations, and adding those equations, after simplifying this, we simply get the sum of the first n cubes is n into n plus 1 by 2 ka whole square. Sorry, it is here square. Now we will consider this exercise, this exercise to find the sum of the n terms. Now if we have the series 1 into 2 plus 2 into 3 plus 3 into 4 plus so on, so this means that first term is 1 into 2, a1 is 1 into 2 here, a2 is 2 into 3 here, a3 is 3 into 4. So we will find its general, or we will consider its nth term. Now here the first factor of this first term is 1, first factor of second term is 2, third factor of third term is 3. So this means that for nth term first factor is n, that is this n. Now the second factor of this first term is 2, second factor of second term is 3. Similarly for nth term second factor should be n plus 1, that is n plus 1. So n into n plus 1 is the general term for this, which is n square plus n, which implies that the summation k runs from 1 to n, ak is actually a1 plus a2 plus a3 up to an, which is actually the sum of the first n terms of this, which is k, summation k runs from 1 to n, k square plus k. So it is simply by distributing k, it is k runs from 1 to n, summation k square plus k runs from 1 to n k. This, it is actually, first one is summation of first n squares, it is n into n plus 1 to n plus 1 upon 6, and summation k runs from 1 to n, k is actually the sum of the first n numbers, which is n into n plus 1 by 2. Similarly, if we consider the series 3 into 1 square, 5 into 2 square, 7 into 3 square, similarly 9 into 4 square. So first term is 3 into 1 square. So this means that the nth term of this is, or the general term is, second factor is 1 square for first, 2 square for second, so n square for last, nth term. So it is n square. Now the first factor of this first term is 3, first factor of the second term is 5, so odds starting from 3. So we can write those odds of the form of 2n plus 1, because when we substitute n equals to 1 in first factor, we get 2 1s are 2 plus 1, that is 3 for first. For second, n equals to 2, it is 5. For third, n equals to this 3, it is 6 7. So in this way, nth term is 2n cube plus n square, which implies that summation k runs from 1 to n, an is, summation k runs from 1 to n, it is actually 2n cube plus n square, that is 2k cube plus k square, which is summation k runs from 1 to n, 2k cube plus summation k runs from 1 to n, k square. Now 2 is constant, it comes out, summation k runs from 1 to n, k cube plus summation k runs from 1 to n, k square. Now using the sum of first n cubes and sum of first n squares, it is 2 into n plus 1 upon 2 square plus n into n plus 1 to n plus 1 upon 6. So this is the required sum of the first n terms of this series. Now the fourth one is 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4. So we will firstly find its, or form its general term, that is an equals n upon n plus 1. 1 upon n into n plus 1, because for first term, first factor in the denominator is 1, in second term, first factor is 2, for third, first factor is 3, which implies that for nth, first factor should be n. Similarly 2, 3, 4, we get n plus 1, because each is greater than 1. So this can be written as 1 by n minus 1 by n plus 1. Hence sum of n numbers is a1 plus a2 plus an. Here a1 is by putting 1 equals to, in this equation it can be written as 1 by 1 minus 1 by 2 plus 1 by 2 minus 1 by 3 plus so on to 1 by n minus 1 by n plus 1. So cancelling this, we simply get 1 minus 1 upon n plus 1, which is simply n by n plus 1. Here series is 5 square plus 6 square plus 7 square up to 20 square. So we have only 16 terms. The first term is 5 square, which implies that the nth term of this is n plus 4 whole square. Because if we put n plus 1 4 whole square, for n equals to 1 it is 5 square. For n equals to 2 it is 4 plus 2, that is 6 square. For n equals to 3 it is 4 plus 3, that is 7 square. So for n equals to 16 it is 20 square last term. This means that Sn is summation k runs from 1 to n, replacing k in an, replacing n by k in an, that is summation k runs from 1 to n k plus 1 whole square, that is k runs from 1 to n k square plus 16 plus 8k, which is summation k runs from 1 to n k square is actually n into n plus 1 to n plus 1 upon 6. Now here summation 1 runs from k to n 16. It is actually 16. We have to add 16 into n times, that is 16, simply 16n, and 8 into summation k runs from 1 to n k is n into n plus 1 by 2. So after simplifying this, we get this is the required sum of the n terms, but here we have only 16 terms, so we have to find the sum of the 16 terms. Replacing n by 16, we simply get as 16 equals to 2840. Now the another question is 3 into 8 is first term, 6 into 11 second, 9 into 14 third term. Now the general term is here, for each term first factor is the multiple of 3, because for first term first factor is 3, for second first factor is 6, similarly for nth it should be 3n. Second term is 8, 11 and 14, so they are connected by 3n plus 5, which is simply an is 9n square plus 15. So summation k runs from 1 to n, ak is actually a1 plus a2 plus an, which is summation k runs from 1 to n 9k square plus 15k, so which is simply 9 summation k runs from 1 to n k square plus 15 summation k runs from 1 to n k. K square is n into n plus 1 to n plus 1 upon 6 into 9 plus 15 by 2 into n plus 1. Now the last one is 1 square plus 1 square 2 square plus so on to 1 square 2 square up to n square. First term is 1 square, second term is 1 plus 2 square, third term is 1 plus 2 square plus 3 square. Similarly nth term is an is 1 square 2 square plus so on to n square, which is actually n into n plus 1 to n plus 1 by 6. After simplifying this, it is 2n cube plus 3n square plus n upon 6, which is this. So Sn is summation k runs from 1 to ak. Put ak equals to 1 by 3 k cube plus 1 by 2 k square plus 1 by 6 k, and using sum of first n cubes, n squares and n natural numbers, we can get it is sum. So in this way you can find the sum of any sequence whose terms are given or whose general term is given. So inshallah, in this way we completed this sequence and series. From tomorrow onwards we will discuss another chapter. So thank you.